A very good morning, everybody. Thank you very much for joining us in this session this morning today. I hope everyone is well and good. And this morning, what we will talk about in the sharing this morning, right, as what the theme of the event is today is about operational technologies and can we really get machines to talk to us, right? And this is actually a very key concept of Industry 4.0, where we talk about machine-to-machine communication and, of course, machine-to-human communication, right? We want to, understand, right, what are the possibilities of communicating with the machines and how we can utilize that kind of information or communication from machines to be able to make the right decisions at the right time, and of course, make faster decision-making process as well, right? So the topic of my talk today will be getting machines to talk through data automation. And how we do that is using or utilizing smart factory enabling technologies, which I will share with you today, right? So we'll go through a few topics this morning. So one of it will be the importance and value of data in a smart factory. Right, I think that is a very, very important topic because many people always think that Industry 4.0 is all about automation, right? However, we usually provide a different perspective where, Industry 4.0 is more about data and connectivity. Automation is actually part of Industry 3.0, which I will talk about a bit more later. Now, the next topic we'll talk about also is how do machines communicate. Right. When we spoke to many industries, right, many factory owners, right, the problem there is that they understand what Industry 4.0 is all about, the bigger picture, right? But when it comes to really going into details of how machines talk to each other, many a time they have a lot of questions, right, on how they communicate, and it's really not a very magical concept. But this is something that I will share with you today. And of course, at the end, we'll talk about a step-by-step approach on how to get machines to communicate to each other. So Industry 4.0, as we all have seen this chart probably a number of times, right? Why I put this up again is to actually emphasize on the fact that Industry 4.0 is about connectivity, right? It is about, connected devices providing data and information in real time for industries to be able to make the right decisions, right? And making the right decisions also mean that you are making data-driven decisions rather than, gut feeling decisions, right? So through Industry 4.0 technologies, that's where you are able to actually understand what your machines are trying to tell you and what the overall data and trends are trying to tell you in terms of your production productivity, right? Now, the understanding of the value of data, right, comes from, the concept of the DIKW pyramid. DIKW stands for data, information, knowledge, and wisdom, right? So what this means is basically when you have much data, right, a lot of data from the factory floor, what happens is that you have basically a lot of information, right? And this information then translates to knowledge, right? Knowledge about your production, knowledge about your machine, knowledge about your process, right? And from that knowledge, right, what happens if you have a lot of data, a lot of information, a lot of knowledge, eventually what it becomes wisdom, right? And wisdom will then be able to, help you to make better decisions in the future because you know your process inside out, you know the trends, you know the analysis, you are the subject matter expert, and therefore you can take your process or production to the next level, right? So we talk about wisdom where you can forecast data and information to make more predictive and prescriptive decisions for the future. So the stages of Industry 4.0 over here, how do you get from data to wisdom, right? It's all about digitalization as a first step, right? When we talk about this is looking at the graph of the stages and the value created from it. So of course, when you have a lot of data, you need to make sure that you are computerized, you're connected. Therefore, the data will give you visibility, right? Understanding it will give you transparency, right? The information that you get will help you to make more predictive capacity. That means what will happen, right? Eventually. And of course, the one that creates the most value is what can you do with that data and what do you have to do next, right? Which is more on the prescriptive and adaptability kind of concept, right? Where you can look into systems that are self-optimizing. You can look into production capacities that will give you suggestion on what to do next. For example, how Facebook and Instagram all works, right? By creating sales, right? It's basically by providing suggestive posts for you to create value and for you to purchase products, right? So all these are basically based on data that is created by you on a daily basis. So the 4 types of data analytics actually comes back to what is data trying to tell you, right? How is the machine trying to communicate to you through data that you gather from the machine? So we start from descriptive. Descriptive means what is happening, right? In a current production system, it's basically telling you what is actually happening in your current system, what is actually happening in your production capacity. And of course, the next thing is diagnostic, right? Why is it happening? So the question of, let's say, machine is down, why is it happening? And usually a lot of times when the machine is down, we don't record why is it actually having a downtime, right? We just straight away up the machine and just left it be, right? So all these are not data-driven strategies, right? But if you actually log the downtime, you actually log the root cause, you're actually able to then achieve what we call as predictive capacity, what's likely to happen, right? Based on the data that you collect from the machine, what the behavior that you see in the machine. And of course, the prescriptive part will be, what do I do next, right? So it increases in complexity over time, but the value created from this kind of data analytics strategy, from descriptive to prescriptive, actually gives you a lot more value to create for your industry to then be able to grow more effectively. Now, if we translate raw data from machines, right, to useful information and to human readable information for us to see, is basically looking at a Google Translate for a machine, right? When we look at communication between humans to humans, we talk in multiple languages, right? Like today, the webinar is spoken in English, but we can also communicate in different languages, maybe 1 or 2 or 3 more, right? So machines are the same, right? They also have communication languages, right? Which we call them as protocols, right? And these protocols then provide you what we call as data, right? So the machine, when it is running, it is also providing you information on what is actually happening. So imagine if you collect raw data from the machine and you are able to translate what the machine is trying to tell you. For example, in this sense, you're taking data from the motor, right? So the motor is then trying to tell you that something is happening, right? Anomaly is detected, right? That is descriptive analytics. So then diagnostic will be, why is it happening? Motor has some problems, right? What is likely to happen next? The machine will shut down in 15 minutes. So prescriptive will be, what do I need to do in this time? So the machine will tell you, please prepare spare part replacement, right? So this is how you get machines to talk to you in a language that you understand, right? And therefore you are able to see what to do next and how to improve your production processes. So the next step of it will be, how do machines communicate, right? I think this question is always asked, right? And it always looks complex and complicated, but what I'm trying to share with you today is actually not very difficult, right? It's about understanding the right languages that the machines communicate and how to actually leverage on that to actually help you to connect machines together and then help you to generate data for yourself. So if we look at the whole automation pyramid, right? We talk about the automation pyramid from the field level all the way to the ERP system, right? Everybody talks about ERP today, right? So you talk about field level, which is your sensors and actuators. You talk about your control level, which is your PLC. Supervisory level, which is your supervisory control and data acquisition. MES is your manufacturing execution system, and then ERP is enterprise resource planning. Now, the key question here is, how do you connect from field all the way to ERP, right? Where we talk about vertical data communication, right? How do your field level sensors talk to your ERP, right? How do your field level sensors talk to your control level, supervisory, MES, and ERP, right? It looks like a long stage. Now, it's not only vertical data communication. Now you also have horizontal data communication, right? How do each sensor and actuator talk to each other? How do 2 different machines at the control level talk to each other, right? And how do your MES systems, if you have a few from multiple sites, how do they communicate with each other? Now, this is actually the key question and the key strength on how Industry 4.0 is generating value for the industry. Now, data communication from machines is not something that is magical, right? Basically, machines speak to each other in a common language, right? So from the very, very basic level, it is basically raw signals coming from machines, right? Coming from your sensors. It can either be analog, which is basically, variation in measurements. So analog signals comes from like temperature, humidity, distance measurements. So those are all analog signals. Digital signals are basically ones or zeros. Ones or zeros means it's either on or off, right? So let's say if you look at your production systems, what are your digital and what are your analog signals from a machine? So a very common one would be digital signals come from your tower lights, your traffic light, red, green, and yellow. So it's either red light on or green light on, right? 1 or 0. So some machines, you have temperature sensors, right? So then temperature sensors are your analog signals. So this can already tell you what is happening in a machine from having an analog and digital signal, right? Now, the next part of it, which is a bit more advanced, will be how do machines talk to each other in what we call as communication protocols or machine languages, right? So machines have a way to talk to each other, right? And when you buy machines, it is always important to know what are the possible ports or communication ports that your machine can speak to each other. So the most common type of protocol is Modbus, right? Modbus protocol is a standard that has been around for many, many years. So therefore, many of your machines would have this connected communication protocol or language, right? But some machines have more than one languages that it can speak with, right? For example, if you look at the IO-Link hub over here, right, which I think Jared will speak more about this later on, it can speak in multiple languages. So if you think about it, it is like a central hub that translates machine information or machine languages, right? So if you speak in English, it'll translate in Bahasa. So for example, in the machine languages, if you speak in Modbus, it can also speak in OPCOA, Profinet, Ethernet IP, or many, many others, so that this creates a better translation, right? Or a middle translation between machine and devices. So then if you look at the entire communication strategy, right, from sensor level to field level to all the way to MES level and ERP, right? So from field level sensors, you can connect to a hub, right? Which is basically, it can either be a gateway or it can be an IO-Link technology, right? And this controller level, you can speak in multiple languages. The most common one, it will be Modbus. Profinet will be more Siemens-centric. Ethernet IP are also available. So these are communication strategies to the control level sensors. Now, if you want to talk to your systems in ERP or even in MES, some of the common protocols are like MQTT, right? OPCOA, or even what we call as REST API, right? So understanding machine communication protocols are very important because that will actually help you to drive your machine communication in a much more simpler manner. So as long as you understand what language that they are speaking with, it's already possible for you to gather that data, gather that information, and then you can drive your technology productivity to the next level. So when we collect a lot of data from the machines through a lot of communication protocol and strategies, right, then data is then used to give you a story, right, to tell you a story of what is actually happening to your machine, what is actually happening to your production line, right? So we call it data storytelling, right, through real-time visualization, right? So the most simple way of data storytelling, right, is when you implement OEE in your current production system, what story is it trying to tell you from this availability, performance, and quality, right? So from collection of that data, right, if you put the right strategies in line, right, it will tell you a story of your 6 big losses, right? Every day it will tell you a story of your 6 big losses. So today, your losses are how much in breakdowns, how much in setup and adjustments, how much is in idling, your speed, your defects, and then your startup losses. So every day it will tell you a different story about your 6 big losses, right? And it will tell you where your wastages are, right? And therefore, by minimizing your wastages, right, minimizing your losses, therefore you are able to then improve your productivity and improve profitability, right? Because you reduce your wastages. everybody has 24 hours in a day, right? Regardless of how much we want to expand our production, the limit is always 24 hours in a day. How much waste can you reduce, or how much total productive time that you can enhance within a 24-hour cycle? So then data is then used to tell you a story of what's happening with your machines through different behavioral trend analysis, right? So an example would be a car, right? You're driving a car, you know, and if there's a problem in your car, they will give you signals, right? They will tell you a spanner signal or many different signals, indication that your car has a problem. What if it doesn't give you any signal or any indication at all? What's going to happen is that you're going to drive your car until it starts to heat up, and then suddenly you have a smoke coming out from your bonnet. And when you have smoke coming out from your bonnet, you start to know that your car is going to break down any moment already, right? So you don't want to have that level of possibility happening. So what happens is that, you know, cars these days, they will have other sensors that will indicate, you know, problems at the early stage, so that you have time to then drive your car to the service center and go and fix the problem, right? Before some other major consequences will happen. So this is how data is being used to tell you a story of your current production system, right? We do have many experts, right, who have been working in the industry for 20 over years. When they walk past the machine and they hear the machine give you like very funny sounds, like, you know, they know that the machine has a problem, but it is not data driven, right? It is based on experience. But now you want to use data to be able to validate that the machine has a problem happening, right? So this is how machine data is being used to tell you a story. Now, from data as well, you can also see trends, right, over time. And these trends are basically only understood by subject matter experts in the industry, because you have the domain expertise of what is actually happening in your industry at the moment. So, for example, this chart over here, if I put it up and I show to anybody, right, can you tell me what is happening in this data set? It is actually very difficult for someone who is not in that particular industry to be able to tell you what is actually happening in this particular data set, except that, oh, it looks like it's different at the beginning, and then after that, it looks a bit more standard throughout the next days, right? So what I'm trying to emphasize here is that, you know, the domain expertise in the industry is very important to tell the right story, right? If you don't have the domain expertise, you know, you'll be telling different stories about this trend, and then everybody will have a different story, right? So as an expert, you are the one that will know exactly what the story is supposed to be, right? In this particular chart over here. So the importance of data, right, is key in Industry 4.0 now, right? It's not so much about automation anymore, because a lot of times by having the right data, you are able to actually minimize certain losses. You are able to actually minimize the gaps in your production systems, and you have greater visibility on where you can improve, right? So when you have a lot of data, when you talk about volume, right, you have abundance of it, you can already start to see your trends. Now, velocity is, of course, the speed of when your data is being generated. Is it every 24 hours, every 12 hours, or every 1 minute, right? What is the velocity of your data being generated? Then you talk about variety, right? You need to collect multiple types of data to be able to make better decisions, right? Veracity is basically your accuracy of your data. You don't want to collect data that is not accurate, and then therefore you make wrong decisions, right? And of course, understanding the value of the data, right? The value of it is very important. You don't want to collect data that doesn't make sense, that doesn't create value, and therefore it's considered as redundant, right? So when you have the right data storytelling, you know, in your current manufacturing production system, and get your machines to talk to you, right? You are able to have many advantages already, right? Improving machine utilization, reduction in maintenance costs, reduction in downtime, and many others. There are many key advantages of getting machines to talk to you, right? And therefore, you are able to be able to drive better productivity and efficiency in your manufacturing operations. So now, I have shared with you on how do machines communicate, what is the importance of data. But of course, the next step of it is, what is a step-by-step approach to start your journey in terms of getting your machines to talk to you, right? So for us, technologies should always be modular, compatible, flexible, and scalable, right? Why we always talk about this concept is because, you know, technologies nowadays, it changes very, very fast, right? You know, every year you have a new Huawei phone coming out, a new Honor phone coming out. Every year technology changes, you know, from 10 megapixel, now you have 100 megapixel phone, right? So every year technology changes very quickly, and therefore you shouldn't be limited by the technology that you have today, right? You should be able to then scale up modularly throughout the years that you are operating your industry. So when we talk about technologies and we talk about compatibility, we talk about open communications, right? Flexible communications and scalable integrations, right? And therefore reducing your overall complexity and reducing your overall cost of integration. So for many of the SMEs especially, we always help them to see where they want to get started, right? So a lot of them, they want to go into analytics, they want to go into AI, right? Which is very aspirational, it's very, very good, right? But one key problem there is that machines learn through data, right? And if you don't have data, therefore it's very, very difficult for them to learn. They can learn, but it may not be accurate, right? So therefore, we talk about data generation as a level 1, the first step. Then we talk about data visualization, the second step. Level 3 is data storage. Now you need to store your data because you want to look at historian trends. You don't want to just see yesterday's trend and then forget about the rest of the days, right? Then you talk about formulation, where you want to create valuable insight for your production like OEE. Then only we talk about analytics, right? What is your predictive capacity and what is your prescriptive capacity through data analytics strategy? So when you look at the entire production system, right, we always start off with the ground level of level 1, right? Collect data from your machine first. Now, a key question of people usually asking is that my machine is 10, 15 years old already, right? It doesn't have IoT capability. It doesn't have, you know, all these ports, you know, it's basically locked, right? I can't do anything with it. It's not that you can't do anything with it. There is possibility to integrate or retrofit to collect data from machines. And that is something that you can achieve in level 1, right? You can just pull data or signals from the machine. Remember your digital or analog, right? Pull that signal, gather that data, formulate a OEE strategy from there. Now, then you talk about level 2 and 3, where you want to log data, store data, and visualize. Then you want to look at OEE, then only you see your analytics strategy. So once you actually start this key concept over here, right? How do you want to get started? Look for the right hardware that you can collect data with. That is the most key important, right? So you talk about IoT gateways, right? Where you can collect data from your analog or digital input. Then you talk about IO-Link technologies where you can pull data and information and it becomes a central hub to communicate with multiple and different protocols throughout your integration process. So understanding that communication protocols, understanding your hardware and devices, language capabilities will help you to make the right decisions, you know, on the hardware purchase that you need eventually. Now, all these technologies, then you know how to, you know what are the hardware. Now, what is the next thing? Next thing is the software. When you want to connect your systems together and integrate them together, look for platforms that are highly scalable and open for you to integrate and communicate, right? You need to look at strategies where, you know, it is a multi-level communication, it is an open protocol, and it is supported by a community to help you drive that kind of integration. So, you know, from data collection, straight away, you can visualize dashboards like this, straight away get your OEE information and straight away move on from there, right? And therefore, these kind of technologies will help you to gather insights. Now, this is only for one machine, but you want to then see multiple machine communication. So your technology that you invest in, right, that you want to invest in has to be scalable to multiple platforms, right? And therefore, you are able to visualize data from across your factory line, right? And you're able to control information that is going through, right? Make the right decisions and then make the right communication strategies, right? And then, of course, when you want to scale up, you want to look at further information, trends, and analysis. You know, there are many platforms out there that are available for you to explore, right? Nowadays, technologies move very quickly. There are many platforms for you to explore. and this is an area where we can help to support industries to learn how to build platforms like this, right? And this is actually very, very sustainable, right? Based on our previous webinar series with Mesa Worldwide, we have also gotten an industry panel to share how they have started their journey through developing these platforms on their own, right? Through our training methodologies. So we talk about, modularity. We talk about flexibility, scalability, and compatibility. Why that is a key importance in the whole smart factory integration is because you want to ensure that, you have a cost-effective and sustainable integration for the future, right? And you want to ensure that there are open and scalable technologies, lower upfront investment, and technologies that are readiness to replicate, right? And when we talk about technologies, right, putting in a technology and plug and play does not mean that it is Industry 4.0 already, right? You still have a journey to go where you look at level 1 to level 5 just now, right? What about the analytics part, right? If you want to do data analytics, you have to have access to all the platforms that you're doing to make the right configurations to suit your particular industry. So eventually there's a lot of customization, there's a lot of, R&D required, to actually move to the next step and the next step and the next step, right? So when you work with open and scalable technologies, technologies that are ready to replicate, that are sustainable to grow in the future, you create what we call as maximum value, right? And we always advocate for ownership and active customization for industries so that they are able to then translate whatever that they have learned into real valuable assets for the company, right? The question is always, whether should you, build your own technologies in your current industry. And we always say that that is actually possible, right? So when you have digital transformation ownership, you have sustainable technology integration. What happens next is you actually reduce your cost of integration and improve your ROI very, very effectively, right? So the key part or the key takeaway that I would like to share is, when you look into integration of machine communication, when you want to get machines to talk to each other, always think about whether they have multiple support languages for communication, whether is it modular, how you want to connect different machines across your automation pyramid. That's very, very important. So those are the key concept and aspect of how you want to decide your investment for the next step. Okay, so SHRDC, we support industries to actually move forward in terms of Industry 4.0 through training methodologies, right? So if you do want to get in touch with us, this is how you can, or you can also, get in touch with us through Mesa Worldwide. We are more than happy to support you through your journey. All right, with that, that's all I have to share this morning. Kenneth.
Thank you, Dr. Chua. Thank you very much.